function operations, and compositions. So operations of functions. Let f and g be any two functions. A new function h can be defined by performing any of the four basic operations on f and g. So, little table operation. And then definition. So we've got addition, which would say that h of x is equal to f of x plus g of x. Subtraction, h of x is equal to f of x minus g of x. Multiplication, h of x is equal to f of x times g of x. And division, h of x is equal to f of x divided by g of x. The domain of h, so this is a continuation of the stuff above, consists of the x values that are in the domains of both f and g. Additionally, the domain of the quotient does not include x values for which g of x is equal to 0. So if there's any x values that basically make the denominator 0, then we would remove them from the domain. We probably won't do a lot with this next thing in this section, but just for reference, the power function y equals ax to the b. B is a rational number, meaning It could be a whole number. Or a fraction. And that'll just work like the stuff we did in the last section. All right, and then the big thing that we really need to be concerned about with this section in terms of preparing you for the future is composition of functions. The composition of a function g with a function f is h of x is equal to g of f of x. So the way this is written, we've got f of x is being plugged in for x in g of x. Okay. The other way that you might see this written, I don't think that our book necessarily uses this notation, but you could see it on like potentially an SAT, or like when we get to pre-cal you might see this notation. This would also be the same thing as h of x is equal to g of f of x. So like that little O is like just saying that it's like the composition of that. But our book uses this notation here. At least it looks like in all the problems that I see. The domain of H is the set of all values, or of all x values, such that x is in the domain of F and f of x is in the domain of G. So I'm going to give this to you in kind of like shortened terms. Plug f of x in for x in g of x and simplify as much as possible. Meaning like combine like terms, reduce things depending on like if it's like a fraction, like if it's rational or something like that. So and something else to note about this stuff, with composition functions, we always work from the inside out. And sometimes they may give you an x value to be plugged in for the functions. There's a couple different ways you can do it, and different teachers tell you different ways to do it. I say plug it in at the beginning because it makes your life a lot easier, actually. But if you plug it in at the end, like that's fine too. That just means you're dealing with more x's and stuff that you could basically be getting rid of. To make your life easier. So I always plug it in first, but some teachers will tell you you need to plug in the function and then plug in the x value at the end.